Hello grade 12s, here's another quick video on solving log functions. Before you start, just make sure you know the log properties because the log properties are really important when you're solving the log functions. Also, just another little tip, there's kind of three kinds of solving. So the first situation is if there's logs on both sides, and if there's logs on both sides, you'll condense the logs using the laws and then get rid of the logs since they're the same on both sides. The second kind is if there are logs on only one side. If there's logs on only one side, still condense the logs using log laws, and then you'll switch it to exponential form once it's as simplified as it can be. The third kind is if there are no logs. So if there's no logs, then you actually just have an exponential equation. And so to solve an exponential equation, you can put a log with base 10 on both sides, and then use the log laws to bring the exponents to the front, allowing you to solve. Alright, so let's try some examples here. Example 1, just as solved. Notice here that I have logs on only one side of the equation. So I'm looking here at the second situation, there's logs on only one side. So the first thing I'm going to do is condense the logs using the laws. So I see that they're subtracting between these. And remember, to condense them, then we divide. So this becomes log of y divided by 5 with the base 2 equals 4. Now once it's condensed as much as it can go, we're going to switch it to exponential form. So this becomes 2 to the power 4 equals y over 5. 2 to the power 4 is 16. And then we can just multiply that 5 out to get a y value of 80. Remember then to always go through and check by plugging the y value of 80 back in here to the equation. So we'll get log 80 with the base 2 minus log 5 with the base 2 equals 4. And remember that this is log 80 divided by 5, which is log 16 base 2 equals 4. And that is true, so my answer is correct. Now let's take a look at the next problem. The next problem, I see that I have logs on both sides. So again, we're going to condense using log laws. So I see that there's some front numbers here. So a leading coefficient becomes a power. And then I'm also going to be adding, so we multiply, and subtract, so we divide. So this will become log of x cubed times 3 divided by x squared with a base of 5, which is equal to log 12. Now we're going to simplify this middle part a little bit more. Again, this is 3x cubed divided by x squared. So if you cancel out the x squared from top to bottom, we're just left with 3x. So really, this is log of 3x with base 5 equals log 12 base 5. So that would be condensing the logs using the log laws. Now once it's condensed, we can get rid of the logs on both sides because that part's already the same. So we just end up with 3x equals 12. Divide out that 3, so we get x equals 4. Now we would go through and check this answer. I've already done that, and 4 does work. Alright, let's look to the third problem here. And the third problem is there are no logs. So that's here, this case 3. There's no logs. So if there are no logs, you can put a log on both sides. And the log we're going to put on both sides would be a base 10, because that is something that we can calculate with our calculator. So again, we just put the log on both sides. The next step is then we're going to bring the exponents to the front using log laws. So I'm going to move that 3x to the front. So we get 3x times log 4 equals log 35. And again, these logs are all base 10, so we can calculate them in our calculator. Before I do that, I'm just going to move this log 4 to the other side, just so that it's not with the x. And then again, this part that's log 35 divided by log 4, we can just type that into our calculator. So this equals 2.56. Then divide out that 3, so we end up with an x value of 0.85 approximately. Again, check that answer, but I already have. So when you check it, it does work. And those would be then, again, the 3 different types of log equations that you might find.